So dual nature of radiation and matter. What are the important formulas in this chapter? Let us first of all let us learn about photon. Okay, I don't want to explain the introduction part, that is not required. Photon, listen, the light is actually is in the form of photon, right? Clear? For example, there is a lamp. Okay, there is a lamp. If the light is emitted from this lamp, the light is the flow of, actually it's a flow of photon. You agree with me? Clear?
Yes, sir.
Can you see the screen?
Yes, sir, I can see.
Yes, actually it is a flow of the energy packets which is said to be the photon. Okay, each photon has certain energy, right? Clear? Each photon, a single photon has an energy. So let us learn about some important parameters of photon. One is a photon has a wavelength. Clear? A photon has, one is wavelength. Wavelength is equal to, denoted by lambda, right? Clear? Hello, listening?
Yes, sir.
Wavelength equal to lambda. Frequency equal to mu. And you know the speed of this photon is the 3 into 10 raised to 8 meter per second. Clear?
Speed of light.
Yes. So you have studied in another chapter waves, that the speed of the wave, that is c here. Understood? The speed of the wave here c equal to lambda into mu. Understood? Clear?
Yes, sir.
This formula is required because if lambda is given, we can find out mu. Mu is given, lambda can be found. So so for different radiations, this lambda and mu will be different. Clear? Lambda and mu will be different for different radiations. So but their product will be a constant. What is the value of c? C equal to
3 into 10 power 8
meter per second. Okay, so this part is clear to you. The next is, what is the next set of formula? So the next is energy. Each photon has energy, right? Clear? Energy of photon. What is the energy? Let me denote by some letter, say A, E. What is the energy of the photon? Do you know that? Equal to h into mu. Okay, clear?
Yes, sir.
Please memorize this formula. Each photon carries certain energy. Clear? Because so if this photon hit with the electron, hit the atom, the electron will be emitted. This is due to the fact that the photon carries certain energy. Understood? Clear?
Okay, sir.
Photon has zero mass, but it carries some energy. Okay, so energy of a photon equal to h into mu, where h is called Planck's constant. Understood? Clear?
Yes, sir.
Oh, you have to memorize the value. H is a constant. Do you know the value of h?
6.626
Yes.
into 10 power minus 34 joules.
Joule second. Very good. Okay. So this energy equal to h mu. Okay, this formula can be written in different ways because you need to memorize all the formula. See here, in some cases mu will not be given, lambda, wavelength of the photon will be given. Okay, you know that. Look here, mu can I write mu as c by lambda? Understood?
Yes, sir.
Mu can be written as c by lambda.
C by lambda.
So this formula can be rewritten as
HC by lambda.
hc by lambda. Understood? Clear? Okay?
Okay, sir.
This part is clear. Let me explain a few set of formulas. I will not start the photoelectric effect. Let us learn about photons. Okay? Photon.
Okay.
Then another one is every moving object will have certain wavelength. You agree with me? Clear? every moving object, not only photon, it can be electron, proton, neutron, every object having certain mass, if it is moving, it has wavelength. Clear? That is said to be de Broglie wavelength. Understood? De Broglie wavelength. Lambda. Okay, lambda equal to, if an object is moving, look here, an object has certain mass, m, and it is moving with the velocity v. Understood? Clear?
Yes, sir.
Velocity equal to v. After explaining this formula, I will discuss the problem. An object having mass m and velocity v, then it has wavelength, that is de Broglie wavelength, lambda equal to h by p. Okay, clear? Lambda equal to h by p, where h is constant, Planck's constant. P is the momentum.
Momentum.
Yes, momentum. So this is h by mv. If mass and velocities are given, we will multiply them, we get momentum. Understood? Clear?
Okay, sir.
Okay, the momentum we have already studied, so this formula I don't want to show. In most of the cases, the energy, kinetic energy of this moving object will be given. Clear? This moving object will have kinetic energy. In most of the question, momentum will not be given. Momentum will not be given. Instead of the kinetic energy of the moving object will be given, you have to find out lambda. So you have studied that, I don't know whether you remember or not. Momentum is related to kinetic energy by this formula, root of 2m
2m
ke or k. Okay, let me use capital letter so you will not get any confusion. Okay, 2mk. So in most of the question, momentum will not be given, only kinetic energy will be given. So we can use this formula where m is the mass, k is the kinetic energy. Understood? Clear? Okay, so there is one more case I would like to explain that. Okay. Okay, there is one special case that I will explain with the help of problem. So you understood all these formulas? Okay.
Yes.
And there are a few set of formulas, but I will explain it just before the problem, that is better. So these are the basic formula related to photon, and de Broglie wavelength means every object having certain mass has certain wavelength, that is de Broglie wavelength. Okay, so can we do the problems?
Yes, sir, we will.
So let me do the problems. I will send the PDF. Okay, so you need not write everything. Okay, so let me discuss problems. There are certain formula, but I will discuss that just before the problem. I think that is much better. Okay,
Yes, sir.
you please read this question first of all. 1 minute.